If you want to use Docker for your home server or media server, then this is the video for you. Let's see how to get started with the ultimate Docker media server. What's up, Geek Army? Anand here once again. We're gonna continue the journey of building the ultimate Docker media server. If you have been following my videos, then we should already have Docker installed in an Ubuntu server environment, either in a bare-bones system or inside a Proxmox LXC, as in my case. In my last video, we saw how to mount some remote folders inside this Ubuntu server. We used rclone, which I highly recommend, by the way, to mount SMB shares from a Synology NAS on the Ubuntu server. Now we're ready to start building the ultimate Docker media server. For this, as always, we're going to use the guides from my website, the Ultimate Docker Media Server Guide, which I updated earlier this year, and also my GitHub repository. It takes a lot of work to create those guides and maintain my GitHub repository and now create videos. So if you really like my work, like and subscribe. I would really appreciate that, and it would motivate me to do more. And while you're at it, also hit the notification bell, because I have many videos planned and it would be really nice to get notified when they come out. This is going to be a long video, so I will cut out the blah blah as much as possible, but I will just tell you why you should be using Docker to build your home server or media server. In the past, until about 2018, I was installing the apps natively on Ubuntu server. This was a lot of work, and when I had to move my server, it was a nightmare. Then I started using Docker and Docker Compose, and it changed everything for me. And I have moved my server many times since then, and every time I'm back in just about an hour with all my settings and configurations intact. Docker, like Proxmox LXC, as I explained previously, removes the overhead of a full-blown operating system and still isolates the application from the host operating system. What does this mean? You can install and destroy the apps as many times as you want, and your host operating system would pretty much be unaffected. I will stop here, but if you really want to learn more, I highly encourage you to read my Docker Media Server Guide. And right now, in this video, let's just get started with building the ultimate Docker Media Server. Okay, we're gonna start off where we left off last time, which is with this Proxmox LXC container called UDMS for Ultimate Docker Media Server. I'm already SSH'd into this Ubuntu server. I ran the sudo apt update and sudo apt upgrade commands, and as you can see on the screen, so we're ready to start building the server. For this, now let's go back to my guide right here, link in the description below. So if we scroll down right there, there's a lot of basic information in here. I'll let you guys read it. If I zoom into this image, you can see how everything fits in. Basically, a lot of things happening, lots of apps talking to each other. All of the files are downloaded into my Nook, which I don't use anymore. I will describe later. And everything is then passed on to the Synology NAS, which stores everything and passes it back onto the Nook or the home server, which then serves all the files and media to the clients in my home. This is how everything fits in, at least in my home environment. So let's close this out and keep moving. Here is the mini PC that I recently upgraded to. It's the Top 10 B700 mini PC. It has dual 2.5 Gbps LAN, which has been really helpful. I will put the link to this PC in the description below. It is an affiliate link. If you like it and use my link to purchase, I get a small commission, and I would really appreciate that. Moving on, we've already installed Docker. We've already created a new user by now. If not, go back and rewatch my previous video. Here we are now to get started with the ultimate Docker media server. The first thing we're going to do is create the files and folders that are required for our Docker. Now, there are different philosophies. Some people like to put their files in /opt folder, which is in the root. I don't. I like to keep everything in my home folder, because usually my home folder is in a different partition or in a different disk entirely, and it really helps me preserve all my settings and everything, irrespective of my, if something happens to my operating system or I decide to upgrade it, all my files are still intact in a different partition. So this is why I like to keep all my Docker stuff in my user folder. So here's the structure that we're going to use. So in my case, as you can see, let's go back here. I'm gonna zoom in just a little bit so you can see what I'm doing and clear the screen out. If I do pwd, you see I am in my home folder. Here's where we're gonna create all of the files and folders that are listed in here. You don't have to watch everything, so I'm gonna keep doing it on the background and fast forward, and in the end, you will see what I have created. So let's start creating some folders. mkdir docker, and I'm gonna go in. Okay, I went ahead and created all the files and folders that are required as described in my guide right here. Let's talk about the folders and files that we just created. .env is the file that will store some of the key variables that we would need and keep reusing them. So this would be the environment variable file. Next, we have the app data folder. All of our apps will be storing the data inside this folder. Then we have the compose folder, which in turn has another folder inside. So if I go into cd compose and do an ls, you're going to see udms. I like to keep all the compose files for different hosts and different folders. So in this case, it is udms. That's why you have this folder. We're going to put all the compose files for all of our apps inside this udms folder. Okay, going back and doing an ls-al once again. Then we have the Docker compose file. Again, I have many Docker compose files. I really like to append or add a suffix of the host name, in this case udms, to the compose file so I know which one is for which host. Why do I do it? As you guys may know, I push all my files to my awesome GitHub repository right here. You can see all the Docker compose files coming from different hosts. This is why I have the host name attached to it. It's your choice. You don't really have to add the host name to keep it simple if you want. Then you have the logs, which is going to store all the logs from traffic and a few other different things. We have the secrets folder, which we may not be using in this guide, but it's good to create that anyway, so we created that. And then we have the shared folder where we might add some files, not in this guide, but maybe in future guides. So here's the thing, we just have to make one minor change here. We're gonna change the permissions of .env and the secrets folder. So sudo chown root.env and type in our password. Then we're gonna do the same for the secrets folder. Okay, and we're gonna change the permissions too. So sudo chmod 600.env and sudo chmod 600 secrets. Okay, so everything now should be the same as in my guide right here. So let's go back here. Here you see everything. So all the explanations are here. Feel free to go back and check it out later. Then there's one thing that I really like to do as well, which is to set the ACLs. ACLs, in my experience, have removed many of the permissions issues that I have faced in the past. So what we're going to do right now is use the ACL command to let the operating system know that the Docker folder that we just created and anything that would reside in it, or any new full files and folders that we will create in future, the user Anand will have permission to read and write. So how do we do that? So we're gonna go back to one level and we're gonna use sudo set facl. By the way, maybe some operating systems do not have ACL installed by default, so let's install that. Sudo apt install ACL, and now the installation is complete. So now let's use the command right here. Once again, you can go back and get the commands from right here, copy paste them. So let's do this. Let's change the permissions first. Sudo chmod 775 docker sudo set facl --rdm user Anand read write execute and docker. And now this will be the default permission for any files and folders created inside this Docker folder. But what about those that already exist? So sudo set facl, you just have to leave out the D and repeat the same command, rwx Docker. There you go. So now we've set the permission. So if I do an ls right now, you're going to see a plus sign right next to the Docker folder. So if I go to Docker now and do the same thing, you're going to see plus sign. That's what is telling us that the ACLs have been set for these folders. So if you want to see the ACLs, then we can do a get ACL and anything. Let's do app data, and then I made a typo, so let's get FACL app data, and now we should see the ACLs that we have just set. And as you can see, the user Anand has read, write, and execute permissions. Okay, so let's go back to the guide right here and keep moving. Once again, I just want to remind you that we mounted the remote folder last time using rclone. I didn't even check it. Let's just make sure that it's available for us. We mounted it under media, and let's do an ls. Let's go to rclone, and there you have my Synology NAS, and let's do an ls. There you go. All my files are still here. So this is what we're going to use when we start creating the ultimate Docker media server. I sound like a broken record, but deal with it, guys. Okay, move into this folder, and let's keep going. Then we already did this, setting the environment variable and the permissions and owned by root, so we can skip that step. Next, we're going to create some environment variables, right? So copy all of the stuff. We're going to do nano env, use vi editor if you prefer. Vi versus nano, it's a different conversation. I'm not going to go into that. I like nano for simplicity. So we just copy pasted everything from there. So UID is 1000, group ID is 1000. My time zone is Europe Zurich. User directory is the user dir is the variable we're setting, and that is pointing at home/Anand, and the Docker dir that we just created is home Anand Docker, and the data dir, as you can see here, media/storage. Now that's not what we called, so we called it rclone DS918. So we're going to change that to that, and then the host name is UDMS. So let's save this and exit. There's one thing here, note the 1000 there. How do you get that information? If I do Anand ID and Anand, you're going to get the information for the user. So UID is 1000, GID is 1000. These are the two numbers that we are using in the environment variable. Okay, now in my guide, I start with some of the basic commands that you can use, but we'll just deal with it as we go. So we are actually now ready to start creating our compose file. We already created the compose file. So what we're going to do right now is open the compose file up and start pasting compose bits from my GitHub repo or from my guide. One reason why I really like Mobaxum, which is the SSH client that I am using right now, is that I have an SFTP browser on the left, so I could start editing files from right here. So here's the Docker compose file we have just created. So I'm going to edit that, and it opens up right there. So let's start creating the file. Now this version tag used to go right at the top right here, just like that, but this is not needed anymore, so we're not going to put that. This is a very recent change. Then we're going to create some networks. We are going to connect all the apps to certain networks, and we need to create the default bridge network. The default network will apply to all the containers that we do not explicitly specify a network. All of those apps will belong to this default network. Okay, moving on, then we're gonna add a few more things. Let's just copy paste this stuff. We already have the top part right there. We created the network. We will do the next part right here. You have to be really careful with spacing in YAML in case you didn't already know. So watch out for the blank spaces in the front and all of that stuff. So here we have some comments to explain everything. Feel free to read through that. We defined the network. Then we're going to start including the compose files. This is what the include command does. Previously, I had one big Docker compose file that had all of my services. Now, recently, I moved away from that and I started breaking down all the services into their own compose files. And I really like that because it makes the management very, very easy, and it also integrates very nicely with what the auto traffic script does, which, in case you're not familiar, right there, auto traffic, it really makes setting up Docker and Docker related apps very easy. Now back to the guide right here. Now we did that. So now we're really starting to create our services. Now there are some preferences right here. You don't have to do exactly the way I do it, but I name some of my services as core, some of them as apps, and whatever you want to call it. Some of them are media apps. So let's start creating some what I call core services. So I'm going to copy paste the core into this folder right there, go down, paste core, and go back in here. The first container that we're going to add, our first service we're going to add, is socket proxy. Docker socket needs to be protected. Let's say you have an app that needs access to the Docker socket, but that app is compromised or using a bad image. Then theoretically, any hacker or an attacker that gets into this Docker container can start controlling your host as well. So it's really important to protect your Docker socket. This wasn't the default in my previous guides. Now, starting the 2024 version, I have implemented some security features by default. So we're going to start by setting up the Docker socket proxy, which provides us with a little bit more control over what is available for different services. So that was socket proxy. So socket proxy does need its own network. So we will have to create that network. So only apps that belong to the socket proxy network will have access to the Docker socket. So let's copy paste that. Well, that's not where it goes. It goes right here under the network. So we copy pasted that. Feel free to customize the subnet. I like the 192.168 subnet, so all of my network is in this range. It makes my management easier. Feel free to customize it as you want. So any container that belongs to the subnet will have IP address 192.168.91.1234.5 and so on. Okay, so now we're ready to start adding our first service. As I said, I started breaking up my services into individual compose files which go into the compose folder. So we're gonna go into this compose folder and into the UDMS folder, and here we're gonna create a new file called socketproxy.yml, and we created the new file right there. And then let's edit this file right now, and here's where our Docker compose file will go. I pre-selected it. We're going to copy the whole thing. We are going to paste it right there. And it's already nicely aligned, no indentation or anything to do. So here, we're just going to make some minor changes here if needed. Here you can see Docker profiles is commented out. It's an advanced feature. Maybe I'll cover that in a future video. And I really use Docker profiles for certain automation purposes. So if you're really interested, check back later. I'll do a separate video on it. Okay, going back to the compose file, we are setting a static IP address for this container 192.168.91.254. Feel free to do what as you please. We are making it a privileged container, so it has access. This is set to true for VM. For Proxmox unprivileged LXC, we're going to comment this out, and we are exposing port 2375 to the local host. Now be very careful with this. Port 2375 is what will give access to the Docker socket. We don't want to port forward from your router to 2375. Then it's essentially opening the door and asking the attackers to come in and have access to all the containers running on this Docker instance. We don't want to do that, but internally we're going to expose this to 127.0.0.12375. We can also use other IP addresses to expose this. It's a topic for another time. It does give us some benefits when used in a controlled, secure environment. Otherwise, if you don't know what you're doing, don't do it. Okay, so then what we're doing is providing access to the Docker socket to the socket proxy container. And then we have a few other permissions right here. what some of the services can do and cannot do. It's been already pre-customized. Just copy paste. We don't have time to go through one at a time right now. So let's save this. It's gonna ask me if I want to save it. Yes, I do want to save it, and it's just uploaded into my SFTP. Now let's go back to the Docker Compose file, and here we are. And what do we need to do next? We added the individual Docker Compose file. We customized it. Here you can also see the explanation on port 2375. Feel free to read through it just in case I forgot to say something right now. And then one thing that is really nice is also to ensure that anytime you expose the port, make sure that this port is available on the host system. In this case, we are exposing the port 2375, and we really have to make sure that port 2375 is indeed available on the Docker host. If we copy paste this command and paste it right there and hit enter, type in our password, we should be able to see all the ports that are listening right now. And we do not see 2375 here. You could also do listen and grep 2375. That will cut out everything, and I get an empty response. That means there's nothing listening on 2375. So we're ready to go. This command is a nice thing to learn because you're going to continue to add more and more services. And when you do, you're going to expose the ports to the host system maybe. And in that case, it's really nice to use this command to ensure that the port is free before you start the container, or else it's going to error out. Okay, going back to the guide now, we created the socket proxy.yml. Now we'll have to add it to our master Docker Compose file. Now we do that by copying this. Let's go back to our master Docker Compose file. There's already a core there, so I'm going to remove that. Now we added the socket proxy container. So let's save this one too. And yes, I want to save it and go back to the guide. And the next step is to start and test if this container starts up or not. For this, we're going to use this command right here. I'm going to copy the whole thing, sudo docker compose, or I could type it up too, but we're going to be here forever because these commands are long. And if you're really interested in how I do it on a daily basis, I use Docker alias or bash aliases to simplify a lot of different things related to managing my Docker stack. So if you're really interested, that's going to be one of the next 1 or 2 videos. So watch out for that, like and subscribe and hit the notification bell so you know when that video comes out. So for now, let's copy that right here. We're going to paste that and hit enter, and it's pulling the Docker socket proxy and starting it up. And now we'll have to check the logs to make sure that nothing wrong is happening. So here is the command to use to check the logs. So we're going to copy this whole command right there. So it's basically sudo docker compose and the path to the location of your compose file, the master Docker Compose file, and then logs. We're adding a few things towards the end so we are able to tail the logs. What does that mean? You will be able to watch the logs as they develop in real time. So let's go back in here. The container has been created. Let's copy the command from there. Obviously, if you're copy pasting, use the right username, and there you go. So here we see that there are some logs right there, and you can see that the socket proxy container started. There are some warnings, but nothing major. I think we're good to go here. So we can move on to the next service. Now we created Docker socket proxy, and any container that will need the socket from now on, Docker socket from now on, they will have to be given access using a specific way. This is the old way of giving access for an app to the Docker socket, and here's how we're going to do it moving forward. So let's take the first example. Portainer is an awesome application. If you do not know that by now, it allows you to manage your entire stack and do a lot of different things. And it needs access to the Docker socket for being able to do all of the stuff that it does. So let's see how to install Portainer using Docker and Docker Compose, and also provide access to the Docker socket. So here we are. We're going to follow the same process from here on out. It's just rinse and repeat, right? So we'll go back in here to the SFTP. We're going to go into the Compose folder, and this one right here, create a new file, just like we did for socket proxy. Call it portainer.yml, or you call it whatever you want. It doesn't really matter. And here is the compose file, compose bit that we're going to copy and paste, right? So let's go in here and we will have to edit this file. So edit right there, and we're going to paste it as is. So we're calling this Portainer. We're using the community edition CE. We're setting it to auto restart unless I manually stop it. And as I explained before, profiles are commented out. Here is where the magic happens now. You will have to connect Portainer to the socket proxy network so Portainer can access the Docker socket. So previously you didn't have to do this, and you can use this uncomment this line right here command and specify the Docker socket right there, but we're doing it the more secure way. So we are going to specify where the Docker socket is available, which is like that. I don't know if I can zoom in. I can't. I hope you can see. Here we're using the TCP port 2375 where socket proxy is making the Docker socket available. And then we're exposing port 9000 right here. You can expose the port 9000 or not. It's entirely your choice. But do not forward port 9000 from your router to the Docker host. It's only useful, this exposing the port is only useful when you want to access Portainer, let's say from your home environment. And this way you can use the IP address of your Docker host and the port number 9000, and you have Docker available or Portainer available to you. Once again, we'll have to use the command as I showed before to make sure port 9000 is available. And this would be a good point to explain as well. In Docker ports, you can see there are two different things. What is on the right side is the port inside the container itself. This rarely ever changes, so do not even mess with it. The one on the left side is the port that will be on the host machine. So this is something that you can customize. So let's say you want Portainer available on port 9001 instead of 9000. You could just change the left side to 9001. Now you can use the Docker host IP and port 9001 to reach Portainer instead of port 9000. But we're going to leave it at 9000. Moving on. Again, previously, if you didn't use socket proxy, you will have to specify the Docker socket as a volume in addition to the command right there above. But we're going to comment it out because we're using the socket proxy. And then keep moving. You are specifying a folder for Portainer to use or store all the persistent data that's going to remain after reboots and everything. And then we're going to look into the environment. We're specifying the time zone. If you remember from our .env file, TZ was set to, at least in my case, Europe and Zurich, and that will be passed on to the Portainer container right here. Okay, so let's save this. This is done. And as we did before, we will now have to call this portainer.yaml into our master Docker compose file. So we're going to do the same thing right there. So copy this whole thing and paste it again. And we're going to change this to portainer.yaml. Okay. Now notice that there is a host name right there, a variable host name right there. This is going to be pulled from the .env file. If you remember, we set hostname to UDMS in this case. Okay, and this is explained right here as well, in case you don't realize that. Okay, now we're ready to test Portainer as well. We're going to use the same command as before, the lengthy one, to start the whole stack. So let's copy this whole thing up and paste it into our... Oh, I'll have to exit out of this log and then paste it right here. And up. Now this is going to start the whole stack. Socket proxy is already up. It shouldn't start, and it should pull Portainer and start it right now. Okay, Portainer is now installed, and now we're ready to access it. But how do we access it? We need to know the IP address of the Docker host, right? So how can we find that out? We are going to use the IP and A command right there, and it's going to spit out all the network interfaces and the IP addresses that they are attached to. So in this case, normally you're going to be looking at something like ETH, and in here it's 192.168.1.187. so this is the IP address that we're going to use. So, okay, Portainer is installed. I already copied the IP address of the Docker host that's running Portainer, and let's do 9000, which is the port number. There you go. Now, setting up Portainer is outside the scope of this video guide, or else we're going to be here forever. So let's move on to the next app from the guide, so we can see a few different examples. Here, scrolling down, then we did Portainer already. Next one is going to be Dozzle. Dozzle is a really nice application that allows you to follow the logs from various containers in real time. It also displays some of the metrics from each of the Docker containers. But to do this, it needs access to the Docker socket. So we're going to do exactly what we did for Portainer and give access to the Docker socket for Dozzle. So let's go back to the guide. Here we are. Here's the Docker compose to use. So let's copy that. Once again, you have access to all of this Docker compose snippets in my GitHub repository. So if I go to the compose folder by different hosts, you can go to different ones and pick any compose snippet that you're interested in. Going back to Dozzle, let's copy this. We're going to create a new file as always. We're going to call this dozzle.yaml, and we are going to edit this right here. And once this is open, let's copy the whole thing right there. Now, once again, I'm not going to go through every single thing. Profiles is commented out, and here you can see in networks we are attaching Dozzle to the socket proxy, so it has access to the Docker socket. In addition, we are attaching Dozzle to default as well. In this case, here inside the container is port 8080, and just for the sake of it, I'm changing the port to 8082 on the host side. So we're going to use the IP address of the host and 8082 to access Dozzle. There are a few different things in here. As with Portainer, we are giving access to the Docker socket using this Docker host environment variable here, and the Docker socket volumes is commented out because we don't need it anymore. Right? So let's save this and let's head over to the master Docker compose file right here, and we're going to do the same thing like we did last time. Copy this and paste it, and there you go. And now we are going to change this to Dozzle, and let's go back to our command line right here and start our stack using this command. Once again, all of these things are long commands. I use Docker or bash aliases to simplify a lot of different things. I will make a separate video on it. If you really are interested in it, would like to see it, post in the comments below, and that way I know which videos to prioritize first. There you go, it's done. Now if I head back into my browser right there, let's go to the same tab. Instead, now we're going to use port 8082, and I should see Dozzle. There you go. So here I can see all the different containers on the left, and you can see some metrics, how much memory I'm using, all the different logs. And if I go into some of these logs, I should be able to see them in real time right here. So here you can see there are some new logs in the socket proxy container, and it tells me there are some services that are trying to reach the Docker socket using socket proxy, probably either Portainer or Dozzle right there. Okay, so we finished Dozzle. Let's keep moving because we still have some stuff to cover. And let's start with the homepage. Homepage is a really nice application that allows you to access a lot of vital metrics, but it also provides quick access and visibility to all the services that you may be running on your home server or media server. I really like homepage for this reason. It's like a dashboard or an entry point to your home lab. Okay, how do we install homepage? It's the same deal. Again, we're gonna copy the compose snippet from right here, create a new file, and let's call it homepage.yaml, and we're gonna edit this once again as we did before. Paste this, and let's see if there's something that we need to edit here. In this case here, homepage also needs access to all the apps that are connected to socket proxy and also to the default network, so it's able to pull the metrics and display it. So we're gonna connect homepage to both networks here. Now, networks is a little bit of a tricky topic. A lot of times people are always asking me, how do I connect one app to another app, let's say Radar to BitTorrent or something like this. What IP should I use? What port number should I use? This is always confusing. For this, you need to know a little bit of Docker networking. So that will be one of the future videos. So watch out for that and hit the notification bell so you get notified. At this point, I sound like a broken record, but so be it. So let's go back to the guide one more time right here. And we copy pasted it. We have pretty much nothing to change here. In this case here, you can see that homepage is creating a new folder called homepage, or this compose or Docker is creating a new folder called homepage inside the app data folder, which is where homepage will store all of its configurations. And we're passing the time zone. We're also passing the user ID and group ID that homepage will use. So let's save this as usual and let's add this to our master Docker compose file right there. Copy this whole line. We're gonna paste it and rename this to homepage, and we're going to start the stack one more time like we did, and let's do that. So now it should start pulling homepage. Now I'm not going to go through all the apps that are listed in here. As you can see, the title of this article is 60 plus apps. Even in the article, I don't go through all 60 apps that you can install with Docker. I'm only showing you a few as an example. From here on out, you can go to my GitHub repo. There are a lot of Docker Compose files here for many different services. You can pull them and start tinkering and start adding. Remember what I said before. The advantage of Docker is that you can start and stop and destroy containers as you please without messing with your host operating system. So don't be afraid. Just get something, start working on it. You will make mistakes, and that's how you learn. That's how I learned. So let's go back and check the status. It's done. Homepage should be on port 3000. Let's go back here and go to port number 3000 and see if you're able to reach a homepage. There you go. Homepage is ready to go right now. So we are making a lot of progress. Let's go back to our Docker Compose, our Docker guide right here, and let's see what comes next. Okay. Media server apps. I believe a lot of people are here for these apps right here. I'm not going to show all of the media server apps here because I'm going to make a separate video on media server apps and how to enable hardware transcoding and all of that stuff. So watch out for that. For now, let's go do it the simple way so you can see how it works. So here you can see the Docker Compose for Plex. We'll skip that. We're going to just go to, because we'll be here forever. So let's do Jellyfin instead. Maybe I have Jellyfin here. So let's keep scrolling. So here you go. I have Jellyfin. So I'm going to copy this one right here. Follow exactly the same procedure that we did from last time. So go back in here, create a new file called jellyfin.yaml, and there you have it. So let's edit this one. Go back in here, paste it. Now let's customize this a little bit. Now here you can see that I am attaching Jellyfin to the default network. It doesn't need Docker socket access, so we don't need to put it on the socket proxy network. The default network is fine, right? And I'm setting it the restart policy to no. What does this mean? Anytime my Docker host reboots, Jellyfin container will not be auto started. This is one of let's say a trick that I do. Why? Because we are dependent on my rclone mounting the media folders from my Synology NAS, as explained in my previous video. If for whatever reason that takes longer or doesn't happen, Jellyfin is going to start and keep looking for that media folder and it won't find it. And I want to avoid that situation. In this case, Jellyfin would start creating a bunch of different unneeded files and folders, and I don't want that to happen. So what I do is that I have a script that watches for the rclone mounts, in this case the media folder. When that folder becomes available, that script kicks in and starts my Jellyfin container or Plex container or Radar or Sonar, whatever, any container that depends on this media folder that will be mounted by rclone. If you're interested in that script, I spoke about it briefly in my previous video, but once again, you will find it here in my GitHub repository if you go into the scripts folder right there. And feel free to explore it. I think it's this one right there, start media after boot. So feel free to explore that if you like. And I might even do a video on it just to explain how it works so you are able to customize it the way you like it. Okay, here we go. So keep going. User, we're specifying Anand and Anand as the user that will run Jellyfin, so we have access to all the required files. This we add for hardware transcoding. /dev/dri is where the GPU is usually located, so we're passing the whole folder or whole device on to the Jellyfin container, so this becomes available also in the same location /dev/dri. So Jellyfin or Plex can support hardware transcoding. I will talk more about it in a separate video. For now, this should be okay. You can even comment out these two lines and it should be okay. Jellyfin will work as long as you have a strong CPU. You should still be able to handle a lot of streaming and transcoding without the GPU. Okay, let's keep moving up. Here you can see we are just defining some ports here. 8920 is not really needed, so we're gonna leave it. The only thing that we're gonna expose to the host is 8096. Inside the container is 8096, outside it's 8096 as well. And then we have a few other things I won't go into. Now we are going to customize the volumes a little bit. Here you can see we are asking Docker to create a new folder called Jellyfin in app data, which is where everything about Jellyfin will be stored. The metadata, the images, the posters, whatever you want to call it, everything will go here. So let's leave that. And we have the data dir. Of course, I provide a generic template in my guide. This will have to customize it. If you remember, my media right now is under /media/rclone/ds918, right? So we're gonna change this to something else. So we did our data editor. If we go back in here, so just to recap, sudo, if I type sudo cat.env, we're going to see all of our environment variables, and data there is already pointing to ds918, right? So we are going to use that data there and my media, and there's a folder called data and there's a folder called media, and we're going to pass this on as media folder 1 into Jellyfin. And then we're doing the same thing because I have two volumes on my Synology NAS. The other volume is data 2. And there is another media folder in there, so that is also something that I am passing into the Jellyfin container, right? And then the last one is that I have downloads that are happening in an SSD that is attached to the mini PC that I just showed before, and we're passing the downloads folder as well. Why? It's not really needed. This is not needed. Usually you just use your media folder, right? So we are here right now, and the last one is dev/shm. This is the RAM. I am passing the RAM from the host system into the Jellyfin container into a folder called data/transcode. This way all the transcoding happens in the RAM. I have a lot of RAM. I have 64 gigabytes of RAM on my mini PC. I can afford to share some RAM for transcoding purposes. In fact, I have 24 gigabytes of RAM allocated to my home server or media server, so a few gigabytes of RAM for Jellyfin to transcode the videos is not a big deal. So I have that right here. Before we move forward, we're going to comment out this line because I don't have the ext environment variable specified in the .env file. In addition, I also don't have any graphics device on this Proxmox LXC because I haven't shown you how to pass through the graphics device from Proxmox host to the Proxmox LXC container, which will be the topic of another video. So be sure to hit the notification bell so you know when something new is published. I have a lot of things planned, so I hope you guys can follow the channel and keep watching for those new videos. But going back to this topic, I don't have a graphics device on this container, so I'm going to comment it out. If you are on a Ubuntu server bare bones system, then you should probably have it as long as your device is a relatively new system that supports Intel Quick Sync, for example. So let's comment this out right now, or else I'm going to see an error. We already commented that one out. So let's save this right here, and we're gonna head over to my command line right here, and we're gonna try to start up the stack one more time. There you go, and Jellyfin just started. So let's check the logs for Jellyfin just to make sure that it starts okay. And I see a permissions denied error. I And I'm glad this is happening right now, so you can see what we can do in situations like this. So let's see, I see a permissions error. So anytime I see a permissions error, so I usually go to the app data folder and do ls-al, so I can see the permissions. So here I can see that Jellyfin container created the data folder with the root privileges. So this is probably what is causing the issue. So I am going to change it, sudo -r on-end and Jellyfin. Okay, so anytime permission error happens, this is something that you can try. Now if I do an ls-al-al, I should see that Jellyfin is now owned by Anand. So let's go to Jellyfin folder. Let's see if I have something in there. There's nothing in there. Now let's try to recreate the Jellyfin container. So how do I do it? Let's go back to this right here, and I will say Jellyfin and force recreate. Let's see if that recreates. And now we're going to check the logs again, and fingers crossed, hopefully we don't have any permissions issues. So let's check the logs again. This command, just wait for, okay, let's see here. Voila, there is no permissions error right now. Everything seems to be okay. Let's just give a few minutes for Jellyfin to start back up here. Something curious, if you guys are sure, you see MB right there. For those of you who don't know, Jellyfin came from MB, so you might see remnants of MB mentioned here and there in Jellyfin. Don't be surprised. So I think it started up okay. So let's go over here, and we're going to change the port number to 8096, which is what we specified. And there you go, Jellyfin is ready to go. So we are right towards the end of the guide. I showed you many different things here. Okay, we're not going to go through the rest of the guide. There are too many apps. This video is already too long, but I think you guys get the principle of what we're trying to do. You basically create the Docker Compose file for the service, you call it and add it into the main Docker Compose file, start up the container, check the logs to make sure there are no errors. If there are errors, or if you see port number conflicts, you know how to see all the list of ports that are already occupied. You know how to change the port number. You know where to change the port number. And if there are any permissions issues in the log, you just saw with Jellyfin, we changed the ownership of the folder that was created by the Jellyfin container. So this gives you enough background to start building your own stack. Read through the rest of the guide, pick any service that you want to try it. If something goes wrong, nothing can happen to your host system. So just get your hands dirty and try it. That's the best way to learn. Okay, back to the guide. Let's keep scrolling here. You can see that I have many different apps listed here. Plus in my GitHub, you're going to see a lot of different things. Now, you did see how much of work this involves, how many mistakes somebody can make, spacing errors. This is why, even though I have the guide that goes into a lot of detail, I created the auto traffic script, which if you aren't familiar with, here you go. There's also a playlist that explains what the script does and everything. It basically automates the whole thing for you. It creates all the folders and files that are needed. It pulls in all the templates that are needed. It can do a lot of things for you, including setting up a reverse proxy so you can access all of the services that you just created externally using a nice domain name, which is not even in the scope of this video, because today we are creating a Docker media server that is accessible only from within our home network. We're not forwarding any ports. We're not doing any other stuff. Anytime you need to access a service, you will have to use the IP address of the Docker host and the port number that was exposed, and you can reach the services that you want. But auto traffic automates everything for you, including adding an authentication layer for security like Authelia or Google OAuth or things like that. So check it out if you're really interested. Now back to the guide. Let's scroll down. One of the most important topics, as I just mentioned, is how do I access these services? Now, the key thing is, if you're inside the home network, you, as I mentioned, use the Docker host IP and the port number that was exposed, and you could reach any of the services that you want. Now, what if you're outside your home environment? Do not forward the port number to the service on your routers to the Docker host machine. Yes, of course, if you want to reach Portainer from outside your home network, forward port 9000 on your router to the Docker host machine and you can reach Portainer from anywhere in the world. But do not do that. That's how attackers get in. Port forwarding is not the best idea. The best approach here would be to use reverse proxies. As I explained in this guide right there, we cannot cover all of the scenarios. The next guide is going to focus on how you can access these services. I keep mentioning guide because I'm so used to writing guides for 15 years. The next video is going to focus on how you can access these services outside your home environment without usage of reverse proxies. Like I said, I have a lot of videos planned, there's many more interesting things to come. So follow the channel if you want to be notified when those videos come out. So here you go. You can see there are many different ways to access the services outside your home network. We're going to focus in on one of these things in the next video. And in one of the future videos, of course, I'm going to cover traffic, which is my favorite reverse proxy that allows us to access any of our services outside the home environment, including with a secure authentication layer on top. Now, if you really want to get ahead and get started with those things and not wait for my video, that's fine too. Here you go. At the top, there is a list of all the different guides that I have. Just go through those in order. We're right now at number 2. I'm showing you how to set up Docker with awesome apps. And then number 5 would be the traffic reverse proxy guide, and you follow that or use auto traffic and you would be able to access your services securely outside your home environment. So there you go. It was a long video. I still have a lot of things that I could have mentioned or explained in this video, but again, I think you guys got what I wanted to convey. There's several resources. My guides are always way longer than my videos, so be sure to check out my guides. There are many different things in my GitHub repo. Check that out as well. And we have an awesome Discord server where there are many people, thousands of people talking about this kind of stuff and helping out each other. So if you really are struggling with something, feel free to join the Discord server and ask for help, and we will do our best to help you. Otherwise, I really hope you guys like what I am trying to do here. I'm going step by step and showing you how I am doing this kind of stuff. If you really like it, follow, subscribe. But what would really help me out is if you subscribe to one of the membership options that I have on my website. No obligations. It would really help me out if you guys did it. I would appreciate the help. Otherwise, thank you very much for staying this long. I will see you in my next video. Go Geek Army.